I'll start with Tally's question, and then as they came in, I'll do them. Any good news today? Anything good to share?
I made a microwave burrito and it tasted good.
Oh, lucky you! I'm starving.
Bookstore gave me my extra book credit back as a check.
Nice. What are you gonna spend it on?
I think I'm just gonna save it. I don't know what I'm spending it on.
I would say breakfast burrito.
True.
We psyched for Friday? You have to be. It's like
You got a long week.
it's like you have a concert or you have a big sporting event. It's yes, Noah. It's you have to have that mentality, right? That you are a superstar performer and that's your big performance, right? And you know. Nice, Caitlin. That's good. You know what's coming, right? You know what the test is like now. You know you have to work fast. You can't doubt yourself. You have to be prepared. Your formula sheet. You've got to be willing to ask questions if you're really stuck on something. You've done all of my old exams, chapter 2 and chapter 3 and the midterms, because basically could be a midterm for you. I could put anything from chapter 1, the chapter 2 test on there, right? The first test. I could put anything on there that I want. And I already did. I did. A few of you that couldn't do problems from the chapter 2 test, and I put them on. Put more of them on there. You have to be able to do these things if you want to pass the class, and more importantly, pass Calc 2, because that's the tough one. That's my job, get you ready for Calc 2. Good. This first question is from Tally. It's just the reason why I ask you to send me things is because I don't have to look through a book. I don't have to look through pages. I can just look at my phone and I can do the problem very easily that way. So that's why I ask for that. Okay? So Tally, we're going to do this one as a quotient rule. Okay? Because I'm sure you tried it as a product rule. So I want to see what it would look like if I do it as a quotient rule. And then you're going to do it over as both. Okay? You're going to do it over as a product rule and over as a quotient rule, because there is one like this on your test. Okay. So I think this was from the homework that I just handed you. Is that correct, Tally? That you just
handed? It's homework 5, question 1. Like the
yep.
first.
Yep. One. So I've got I want a derivative. I've got y equals 2x minus 5 to the 4th times.
Screen isn't shared.
Oh, thank you. Well, you all know the problem. When I share it, you'll shudder. Go, ugh, I remember that problem. Right? Thank you. The chat is open to so let's do this as a quotient rule. Right? Because I can really see it as a quotient rule if I take that negative exponent and move it down, right? So I'm going to do this one like a quotient rule. So it's really your choice on the test. Did I say do it as a product rule? No, I just said make sure it's completely factored. So find y prime completely factored, okay? So upstairs function 2x minus 5 to the 4th, derivative 4 times 2x minus 5 to the 3rd times a 2, right? That 2 is coming from the derivative of the inside, yes? Nice. Downstairs function 8x squared minus 5 to the third, and derivative 3 times 8x squared minus 5 to the second times a 16x. Right, again, derivative of 8x squared is 16x. I can't forget the downstairs squared, right? So that's going to be to the 6th power. Right, when I raise an exponent to an exponent, I multiply them, right? So it looks like y prime now is looking, right? And remember, my loop is this way with a negative. I've got an 8 times a 2x minus 5 to the third times an 8x squared minus 5 to the third. Everyone okay there? That's this piece right here. Yep, nice. Minus, right? It looks like I have, what, 3 times 16? 48, is that right? 48x times a 2x minus 5 to the fourth times an 8x squared minus 5 to the second. And so now I'm picking the order I'm writing things. I'm picking the order I'm writing things so that they're kind of lined up. I don't think you have to do that. I just have found in my life it's easier to do things that way. So I would have something similar, but just a numerator if I did it by product rule, right? But I'd have pieces with a negative exponent in it, right? So I think sometimes it's easier to clear the negative exponents first. It looks like I can take out what, a factor of 8. Is that agreeable?
At least 5 all around.
We can take a factor of 8 out, right? We can take a factor of 3 of these out and a factor of 2 of these out, right? So it looks like I get 8 times 2x minus 5 to the third. Now I showed you a little bit of a different way to do this before, and that was write everything out without exponents so I could see how many are shared. But that's a bit of a waste of time. So those are the pieces that are shared, still over 8x squared minus 5 all to the 6th. And the piece that's left over is going to be what? 8x squared minus 5 to the second minus 6 times 2x minus 5. Is that okay? Tally, you there?
Yeah, honestly, I think what messed me up was the negative exponent.
Yeah. So there's not one on your test, but it's good to do this one over, even with the product rule. Go ahead, up soon.
Sorry, why is 8x squared minus 5 squared? Was it 5 there?
Because Robert screwed up. I took out 2, right, and there's only 3 there. Thank you.
Good morning, Professor, everyone.
Marcus, good morning. What's up?
Yeah, this one was
This is one of the ones I know. So send me the other ones, okay?
Yeah, but the problem is that, like, why did you use the quotient instead of using like the product rule?
Because I can, right? So I could rewrite this fraction first, rewrite this product as a quotient. And so I'm still saying to all of you, you should do it again as a product rule, right?
Yeah, but I was doing it using product rule. Can you try to do it for me, please? Using product rule?
But it's gonna be very, very similar. So I'll start it with the product rule in a second, okay?
Also,
Okay, thank you.
Yes.
Another question.
Off soon.
What? Minus 6 times 2x minus 5. I thought it was like 6x.
Thank you for being here today. You found all my mistakes already. Everybody else wake up, including me. All right, so I'm going to keep going here. Good morning. Did you do the test where you checked your lockdown browser?
No, I have not.
Please do that before Friday. The password on the Chapter 2 test is test123. Make sure your lockdown browser works.
Okay.
By the way, everybody, if your lockdown browser doesn't work on Friday, you will take a 0 on the test, and that will be the test I drop. So I'm just distributing here, right? So keep checking me, please. And I want to clean this one piece up and see what happens here. Yeah, it's a pain to keep writing everything over and over, and you waste paper, but that's the way we do things, right? We try and say a complete sentence every time we write something. So it looks like I have a negative 4x squared plus 30x minus 5. And that's fine as an answer. Some of you even sent me that answer. But we don't factor polynomials, quadratics with the leading negative. So we should take that out. We should take out that negative. So now I have a 4x squared minus 30x plus 5. And I'm going to check that, right? I'm going to check that with my regular process of can I factor it, right? Of course, if I'm looking at the answer, I'll see if it's factored or not. If it's not factored, I know I'm done, right? That's one way to do it. But we should really look at that last piece and make sure it's not factorable. So the way we first ever did it was we said, okay, 4 times 5 is 20. The factors of 20 are 1 and 20, 2 and 10, 4 and 5. Do any of them add to 30? No, right? So add or subtract to 30. So we're thinking it's not factorable, right? In pre-cal, we learned that it's possible to have a factor of this. If I take the factors plus or minus the factors of the constant, which is 1 and 5, over the factors of the leading coefficient, which are 1, 2, and 4, right? Do you remember doing this in possible rational roots theorem in pre-cal? Possible rational roots? Yes, you kind of remember hearing that before? Pedro, would you just send me a question?
No, because I noticed that my homework got corrupted like the first time.
That's fine. It's your homework. That's fine.
Yes.
That's fine. I'll accept it.
Thank you.
You're welcome. So we could try one of these possible rational roots. I prefer to look at the graph and see if one of these makes sense, right? 1 or 5 or 1/2 or 5/2 or 1/4 or 5/4, right? I could scale my calculator to see if it works. Or I could do quadratic formula, right? So quadratic formula says what? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. What I'm really interested in is this inside. If this inside is negative, right, then for sure I'm not going to factor it, right? So it looks like it's going to be positive though, right? 30 squared is what, 600? 30 times 30, no, 900. So it looks like it is factorable, but my roots will be irrational, right? So it's fine to leave it like it is then. We have 900 minus 16 times 5. 80. So it is factorable, but the roots are irrational, so we tend to say don't bother there. I still would need to find those for critical values, right? That would be a numerator equal to 0. So there's my answer for y prime. Markins, I'll after I answer all the other questions, I'll do that starting with the product rule. Okay.
Why don't
No.
we,
Afsoon?
why don't we like cancel out the 8x?
Oh,
squared?
yes, we do. Sorry. Thank gosh. Thank God you're awake. Because I am not. So x squared minus 5 to the 4th, right? If I give you one that's more factorable, that you can factor more, it'll be obvious. You don't have to go through all this process. It won't be as complicated as this. So this one is factorable, but the factors are irrational, so we usually don't bother doing that. If I have to find the critical values, though, I still will have to go through either complete the square or quadratic formula. Tally, okay?
Yeah, thank you.
Do it over with the product rule. Do it over with the quotient rule, okay?
The question is, like the answer that the book gives, and don't have like the fraction bar. It gives like an answer like as a straight line.
So they have a negative exponent in it.
Yeah. It have a negative.
So
oh yeah, now
I would like everything without a negative exponent.
Okay. Yeah, because like they left the negative exponent for. I'm looking on my homework. Yeah.
I would like it without a negative exponent.
Okay. Fantastic. Don't do like with the negative exponents.
Nice, thank you.
Yes,
Okay.
Professor, can you please zoom out for me, please?
I'm sorry, say it again?
Can you please like zoom out for me,
Yes.
please? Like, please.
Oh my God, why are so many people emailing me today? So good. Up soon, I should do this one, okay? How do we know when to use the triangle method in our problems? If you have a trig, you have a triangle. So most of the time, you'll need the triangle, right? Now,
Right.
if I just say to you, find the derivative of sine, you don't need a triangle, it's cosine, right? But if I say
Right.
sine equals something,
Yeah.
right, then you know you've got ratios of a triangle. Do you want me to
Okay.
do? Go ahead.
Please do that. Well,
Yeah.
then maybe you might do the one that's right next to it, because I don't think this had a, never mind.
This
We'll probably go over at one point during class, like one that's equal to something. I know I tried one on the homework that was equal to something. So like
Well,
you
this
try
one is a triangle. Because what's my first thought now? Not if I have a trig, I have a triangle, but if I have an inverse trig, I have an angle. So let me do this one.
Yeah.
Markins, you done?
Yes, I'm doing.
Nice.
Thank you, Professor.
Thank you. So I've got, good morning. Oh my God, I got coffee delivered. Thank you so much. So this is, I don't know which one this is, but this is good because there's one like this on your test, right? So Noah, you asked what's on the test so far. We've got two almost exact questions that's on the test. So here it is. I've got an inverse trig, but I don't think in inverse trigs. I think in trigs, right? So I think I have theta equals arc sine of 2x minus 1. Okay, but I want to think in terms of sine, not arc sine. So I know sine of theta is 2x minus 1. And there it is. I have a trig equal to a ratio. So I know I need a triangle, right? Yes.
This question is from the chapter 3.6, question 19.
Yeah, this is 3.6, inverse trigs, yeah. So sine is opposite over hypotenuse, and I've got to figure out that remaining side. I call it A, it doesn't matter. I just was looking at somebody's this morning, and they called it B. So A squared plus 2x minus 1 quantity squared equals 1 squared, right? I think I might have to FOIL that out, but I'm going to wait, okay? I probably do have to FOIL it out, but I'm going to wait on it. So I get A squared equals 1 minus quantity 2x minus 1 all squared. So a equals square root of 1 minus the quantity of 2x minus 1 all squared, right? And it's hideous. I agree, it's hideous. The one on your test is not as hideous, okay? So far, the two problems that we're doing, the two on the test are easier.
Professor, if we know the rule for the inverse trig, can we use that, or we need to do by this way?
I would expect to see the triangle. I don't care.
Yeah.
I don't care what else you do.
Yeah, because like I know that the inverse sign is 1 over 1 fraction bar square root of 1 plus and minus x squared. Like, yeah.
Yeah, but you're talking about the trig derivative. You're talking about the inverse trig derivative. Yes, everybody has that on their formula sheet, I hope, right?
Yeah.
But you still have to prepare this to answer the question. You have to find this triangle to answer the question completely.
Yeah.
Because what am I going to say? What's my question? Find y prime in terms of what? In terms of x. I want y prime to be some completely factored fraction with x's in it. No trigs. Okay? All right, so now that I got my triangle set up, don't know if I need it yet. Okay? I might need it. I know that I have y equals inverse sine of of 2x minus 1, right? But I have to, so I've got a formula for y equals arc sine of u, right? I need to find, it is what? Y prime is u prime over square roots of 1 minus u squared. I might not need the triangle, but still something from the triangle is going to show up here, right? So what do I need? I need u. U is 2x minus 1. I need u prime. That's 2. I need u squared, right? That is 2x minus 1 quantity squared. How are we doing here? Good. Oh my God, coffee is so good. Okay, so for y prime, what do I get? I'm going right to this formula. I don't, so pretty simple here. U prime is 2 over square root of 1 minus 2x minus 1, that quantity squared. Now look, you can see that from my triangle, but I don't need my triangle, right? That's all I need, right? And so I guess I can kind of simplify this. Let's see what happens if I simplify it, right? So if I simplify that square, I get 4x squared minus 4x plus 1. And then the 1's will cancel, right? And my 4x will become positive, so 4x minus 4x squared. So I'm glad I simplified it because look, you can see a factor of 4 that's shared here, right? Yes, you with me?
Yeah.
So I've got a factor of 4 that comes out there, x minus x squared, and that comes out as a 2, right? That comes out of the radical as a 2. And so my final answer is 1 over the square root of x minus x squared. Chris, what's up?
Why don't we take out a 4x from it?
So when x comes out, it comes out as a square root of x. I do agree it's a shared factor,
yeah.
but I want to take out square factors.
I gotta be careful not to do that.
I wouldn't.
Because it's always the square coming out.
Yeah, I wouldn't necessarily mark it wrong. Afsoon, what's up?
So the rule for like the beginning part of triangle is we introduce theta and then we like switch it up so that it's like sine of theta.
Yep. Yep.
And then outing. And
Yep.
then make a triangle out.
Exactly. And in this case, remember I said about 90% of the time you'll need the triangle? In this case I didn't. It did give me a little insight into, there's a hint there about the derivative of an arc sine. Right?
And if yeah, and if it was like sine or arc sine of 2x minus 1 is equal to like 4, I wouldn't have to introduce theta. I just,
It wouldn't be that way though. It would be something like, it would be tangent of arc sine of theta equals x, right? So tangent equals x, so I need a triangle.
okay.
Yeah. All right, nice. Who is next? Chimaka. Perfect. 25 is implicit, right? And 11 is implicit. 11 sucks, but we'll do it anyway. This is 25. I think this is from 3.5 implicit. So I've got x squared plus y squared equals 2x squared plus 2y squared minus x all squared. And we want to find a tangent line at 0, 1/2. Is that true? Or a slope at 0, 1/2? Chimaka, what is it? Tangent line or slope?
Tangent line equation.
Tangent line, yeah. So on this one, I'd give you a graph because you can't graph this on your calculator. This is implicit, cannot be separated. So I'd give you the graph and ask you to graph the tangent line right on the graph, right? Find the equation, graph it on there, right? So we'll do that. We want to do a derivative of both sides, right? So I'll do that with a prime symbol, right? So you can read my original problem in black, and then you see that I'm going to do a derivative of each side here, right? And so what do I get? I get 2x plus 2y prime. Does anybody need help there? On the left-hand side, I get a derivative of x squared is 2x, derivative of y squared is 2y, but using the chain rule, I get a y prime. And then that's going to be equal to 2 times the inside times the derivative of the inside. And look what I'm doing, because I'm a little nervous or whatever. I'm taking that inside piece and I'm going to put a prime on it, right? So I'm kind of giving myself a little bit of a time to breathe, time to think. So, but now I'm ready to write that piece. So 2x plus 2y y prime equals 2 times 2x squared plus 2y squared minus x times 4x plus 4y prime minus 1. Is everybody okay there? I just did the derivative of that last piece. Nice. Lots of thumbs up. Awesome. Nice. 4, 8, 12, 16, 20. Nice markings. 19 students here. Who the heck is missing?
Man, it is sweltering today.
Yep.
Humidity is crazy.
Yeah, it's so muggy. It's. Go ahead, Epson.
I'm freezing. Where are you? It's not cold.
Montgomery County.
Me too.
Yeah, Montgomery County.
I'm in DC. It's very hot. It's so muggy outside. My wallet's missing. Muggy. At this point, it'd be ridiculous for me to ask you to solve for y prime. So what you do is you put the numbers in right away. So for every x, I'm putting in a 0. Okay? Let me do that first. That's gone. That's gone. That's gone. That's gone. Let me rewrite. 2y prime equals 2 times 2y squared times 4y prime minus 1. So when I put in the x is 0, all my x terms are gone. Now I'm going to put in my y is 1/2. So 2 times 1/2 times y prime equals 4 times 1/2 squared times 4 times 1/2 times y prime minus 1. And so I think I had mentioned this, like if it's a decent problem to solve for y prime, I'll ask you to give me the derivative. If I just want the slope, I'll say give me the slope on the test, right? I like one of these on the test where I give you a graph and ask you for a tangent line with implicit. So it looks like I get y prime equals 2y prime minus 1, right? This cancels to a 1, right? So it looks like I get y prime equals 1. Do we agree? Double check me. Nice, so our tangent line is real simple, right? Tangent line is simple. I gave you a 0, 1/2, so I just get y equals x plus 1/2 as my tangent line. Right? If I give you a 0, the y value I give you is your y-intercept.
So for a problem like this, we didn't have to completely FOIL it out.
You almost, it's such a nasty, nasty thing. So if they ask you just for the tangent line, do you need to find y prime? You just need to find the slope. So in that case, you can just plug in the values of x and y.
It'd be fine if I completely factored it out.
Yes, it just will take a good part of your life away from you.
Probably not the best strategy on the test.
Right, but I'm going to tell you, find me a derivative or find me a slope. Okay? I don't need to graph it. I mean,
And so for finding the derivative, you just find the derivative, and for finding the slope, you use implicit, pretty much.
Well, no. If the problem's implicit, you use implicit. If the problem is not implicit, you don't use implicit, right?
Okay.
But if I say find me a derivative, I want some function. If I say find me a slope, I want a number.
Yeah, okay.
Yep. Okay, the other one is hideous, so sorry about this, but nothing like this on the test. 4 cos of x times sine of y equals 1. But it's good for you to do it. I want the derivative, right? So I'd like to solve for y prime here. And it's obviously, on the left-hand side, it's a product rule, right? On the right-hand side, it's simple. So first function is 4 cos of x. Derivative is negative 4 sine of x. Second function is sine of y. Derivative is cos of y, y prime. Everyone okay there? So I get 4 cos x, cos y, y prime. I find in this case it helps me to put the parenthesis in, but minus, oh, this is not so bad, minus 4 sine x sine y equals 1. Oh, sorry, equals 0, right? It's not so bad. I thought it was worse. Looks like my 4's are going to cancel, right? So I'm going to leave my y prime terms on the left. I get cos x times cos y times y prime equals sine x sine y. And then I just have to divide by that coefficient of y prime, right? So y prime is sine x sine y over cos x cos y. And I guess that would be fine, but if you look at the answer, you'll see a trig identity. So you want to play with those trigs whenever you get them. You see here, I get what y prime is tan x times tan y. Mob, that was yours. Was that? Oh, that was Chiamaka, right? Is that okay?
Yeah. My question was, so because the 4 is multiplied to the cos x, it doesn't cancel out when taking the derivative.
Correct. So if you just looked at y equals 4 cos x and did a product rule there, right? So if you remember, my thought was coefficients go for the ride when you're taking a derivative. We had talked about a coefficient can go in or out of a limit, right? So the coefficient can come out of the limit for the derivative, and then it goes back in. So, but if I did 4 is my first function, derivative is 0. Cos is my second function, derivative is negative sine x. You can still see the product rule. I get negative 4 sine x.
Okay.
Right?
Thank you.
Does that help? Yep.
Yeah, that helps. Thanks.
Nice. Okay, so Pedro just sent me homework. That's fine. Markins says, here's the first one from Markins. Nice. So number 27, Markins, is that correct?
Yes.
Thank you. Sorry. Thank you for your patience. My father used to say, you'll never be a doctor if you don't have patience. So y equals...
What is one I even have to mute? I love it, this one.
So I use x's instead of r's. So I want y prime here, right? So quotient rule, right? So first function is x, derivative is 1. Second function is square root of x squared plus 1. Derivative is 1 over 2 square roots of x squared plus 1 times another 2x. Markins, make sure you work with me there and see if you agree.
Yeah, I see it. Yeah.
Good. Now,
do the rest.
yep, all over the downstairs squared, so the square root goes away, right? So y prime is going to be square root of x squared plus 1. The 2's are going to cancel here, but I am going to get a negative. So negative x squared over square root of x squared plus 1, all divided by x squared plus 1. Not done. What's giving you the hint that you're not done is that you have more than one fraction. Fractions within fractions or more than one fraction, right? So we're gonna clear our interior denominators with square root of x squared plus 1 over itself. Is everybody okay here? Nice. So when I distribute this into numerators, right, it looks like I get an x squared plus 1 minus x squared all over x squared plus 1 to the 3/2. Make sure everybody's okay there. Right? This is to the 2/2, right? So there it is, 1 over quantity x squared plus 1 to the 3/2, and that's my y prime. Markins, what was the problem? Can I guess? You missed this 2x?
Understand. It's like, I don't know, like, I think it was, if I just change it to x, I would have done it, but I didn't do that. That's fine.
Nice. Next one is number 23. Is that correct? And this is all from chain rule, right? So this is 5.3, number 23. And this is y equals quantity cubed of x squared plus 1 over x squared minus 1. Am I doing the right one? Markins here? Afsoon, question?
Yeah, start, yes.
Question,
You
Afsoon?
can,
It's actually on the last step of the last one.
Yep.
So where'd it go? Oh yeah. I like the negative so step 4. So I guess. I like changing the square root to to the 1/2 power, and then same thing for the other one if it's negative 1/2 power.
Yep.
So when I did that, factored out r squared plus 1 to the negative 1/2.
Yep.
And then simplified and yeah, and I got this answer.
Yeah, that's fine. You don't have to do your algebra the way I do mine. Yep, you can do, as long as you're following rules and doing things right, it's no problem.
I have a question.
Yes.
Is it possible to square root the x squared plus 1?
No. So the problem is, if I had 4x squared, I can square root a product. I can't square root a sum, right? So this one is a 2x for sure, right? I can do this one, x plus 1 quantity squared, because that's again a product, and I get an x plus 1. But this guy is a sum, right? So I can't, it's like factoring. You can't cancel factors, add-ins. You can't cancel things from a sum. You can cancel things from a product. And that's exactly what the same idea here.
Thank you.
Yes. Nice. This is a outside function is a x cubed, right? A cubed function. So we know y prime is 3 times the inside squared times the inside prime. Right?
Isn't the whole function supposed to be cubed?
Yes, thank you. And I knew that, but I didn't write it. And thank you, Noah. Thank you, Afsoon, for not being as quick to correct me that time. So now I want to work on this piece with the quotient rule. Upstairs function is x squared plus 1, derivative is 2x. Downstairs function is x squared minus 1, derivative is 2x. Downstairs squared is x squared minus 1 quantity squared. So now I can put in for that placeholder. So y prime is 3 times the inside quantity squared times my quotient rule piece. So it looks like I have a 2x times an x squared minus 1 minus a 2x times an x squared plus 1 all over the downstairs squared. Markins? Okay?
yeah, I get stuck over here in this part.
Yeah, okay, good. Now, you can distribute things out, but it's not the way to go. You should factor. So I can see there's a factor of 2x that's going to come out there. So I'm also going to split this up now just because I know what's coming. And so I got a factor of 2x, and what's left over? An x squared minus 1 minus quantity x squared plus 1. And clearly you can see that there's a 2x in both of these, and that's what I took out, right? So I want to try and factor when I can. So that does simplify. I see I have 3 times x squared plus 1 quantity squared times x squared minus 1 quantity to the 4th, right? I can see these two are going to work together. And now I still have 2x times x squared minus 1 minus x squared minus 1. Nice. So it looks like I get a negative 2 there, right? The x squareds go away. I get a negative 2 times my 2x times my 3. So I get a negative 12x times x squared plus 1 quantity squared all over x squared minus 1 quantity to the 4th.
So how did you get negative?
So there's a negative 1 and a negative 1. So that's negative 2. times another 2x, that's negative 4x, times another 3, that's negative 12x.
Oh, okay. Thank you.
All right, last one. Nice. Oh, and then the product rule one, right? I want to do that first one over with the product rule from Markins. So I've got y equals x arc sine x plus square root of 1 minus x squared. So the first piece, Austin, question. Back to the other one?
Yeah, but you basically already answered this. I just did quotient rule from like the beginning. There was no rule for us not to do that, right?
Correct. Again, you don't have to, you just have to be organized. So however you're getting yourself to be organized, right, that's fine. You can kind of see that this part is just a completely separate thought. So I'll often like say I'm doing a quotient loop here, right, or things, right, because right away I'm writing y prime, and then I want to go to y prime, right? So that little piece is me doing some side work, right? But I don't care what you do as long as I can read it and make sense of it, right? So it looks like I have a product rule here and then a chain rule here, right? Now remember, I always have chain rule, right? But everything's simple there, so it's not much to do there. So y prime is going to be x times inverse sine of x prime plus 1 over 2 square roots of 1 minus x squared times another negative 2x. So Mark and see, I did the piece there that's quick. So
Yeah.
I had a product rule and a chain rule. I did the chain rule piece first, but I put a placeholder, right? I put a little warning sign on. I still have to do a product rule there. So the product rule, first function is x, derivative is 1. Second function is inverse sine of x. Derivative is 1 over square roots of 1 minus x squared. So I'm ready to put that piece back into my derivative, right? This was a product loop here. So it looks like I have x over square root of 1 minus x squared plus the arc sine of x, or inverse sine of x, minus x over square roots of 1 minus x squared, right? Notice that these 2's will cancel. And that now I see that this piece and this piece are opposite, so they will cancel. And there's my final answer. Y prime is inverse sine of x.
Can you please some more, please?
Yes. How come I can't think of who is missing? Oops, sorry. Oh, it's Nahom. He told me he was missing today. No, if you hear that, I recorded like you asked me. And now I realize you're not here. But everybody else is here. That's fantastic. So there's 3 of you that need to log into Chapter 2 test with the password of test123 and make sure you can get in with your lockdown browser, right? If you can't, you need to talk to support at WebAssign, okay?
The 3 is like, you asked every student to do that, yes?
Long
Or
time
just-
ago. You already took the first test. You're fine. As long as you didn't
Okay.
change your computer.
Yeah, no, it didn't
Yep.
change.
Yeah. Nice. Let me go back to the first question with product rule. Then I'm going to give you a rundown of what's going to be on the test, just like I did for test 1. And then we'll probably just quit for today. And then